You know, we hear it all the time, that some people are just naturally gifted. But is that really the whole story? Have you ever stopped to think about how we actually build a skill, a complex skill, right from the very beginning? Today we're going to dig into the architecture of learning itself, and it all starts with a simple question that, well, it changes everything. Okay, so let's just jump right in with this question that seems almost too simple. What's the real difference between the number 999 and the number 9? I know, on the surface it seems pretty obvious, but the answer reveals something really profound about the very architecture of how we think.
And here's the catch, right? That's the part that's kind of weird. Both of those numbers are built using the exact same symbol, the same digit, a 9. So if the building block is identical, where does that massive difference in value even come from?
Well, the answer lies in this really powerful idea that, honestly, we all take for granted. It's not about the digit itself. It's about a hidden pattern, a kind of hidden logic that's baked into the numbers we use every single day.
And that big idea, it's something we all learned as kids, the place value system. It's a concept where a symbol's meaning isn't fixed. Instead, its value is decided entirely by its position, by where it's sitting next to all the other symbols.
Let's break this down with a number we all know, like 99. The 9 on the right, that's just 9 ones, simple. But the 9 on the left? That one means 9 tens, 90. It's the exact same symbol, but just by moving it one spot over, its value completely transforms.
And there it is, the same symbol, carrying a completely different weight, a totally different value, just because of its location. This is the fundamental rule that our brains have to figure out to make sense of numbers.
So, okay, we get the rule, but how does our brain actually learn to use it so fast, so automatically? This is where we move from the system itself to the architecture of how we actually learn the thing. You see, our brains are way too smart to just memorize millions of different numbers. No way. Instead, they learn a simple, repeatable pattern. It's like a mental shortcut. You see the digit, you note its position. Is it in the ones place, the tens, the hundreds? And from that, boom, you instantly know its value. Digit plus position equals value.
Now this system is pretty slick, right? But it does have one little problem. What do you do when one of those positions is, well, empty? How do you show that a value is missing without completely wrecking the whole structure?
And the solution? Oh, it was an absolute game changer. The invention of zero. Just look at the number 205. We've got 2 hundreds, and we've got 5 ones, but we have 0 tens. That 0 isn't just nothing, it's a placeholder. It's literally holding the 10 spot open, making sure the 2 stays where it belongs in the hundreds place. It keeps the whole pattern together.
All right, so let's take a huge step back here, because this whole idea, learning a simple pattern until it's second nature, it isn't just about math, and this is where things get really, really cool. A major psychological discovery showed us that the way our brains learn that place value system, it's the exact same blueprint we use to build almost any complex skill.
And here it is, the crucial insight. What we call ability isn't magic. It's not some mysterious talent that you're either born with or you're not. It's actually a structure, something that gets built piece by piece from tiny, repeatable habits.
I mean, just picture a kid learning to add, right? At first, 5 plus 3 it's a real chore. They might have to count on their fingers, sound it out. But after enough practice, something clicks. The answer, 8, just appears. It's automatic. A really tough task has become an effortless mental habit. And look, this isn't just a nice idea. It's science. Psychologists can actually show that learning is a measurable process. It's not random at all. It follows a clear, predictable path. I mean, how amazing is that? It completely flips the script on what we think ability is. It means our abilities aren't set in stone from birth. They are structures that we build inside our own minds, slowly, deliberately, with focused practice. And every single repetition just makes that structure a little bit stronger. So, if we're all builders, what are the instructions? What's the blueprint? Well, it turns out there's a universal code for learning, a clear path that can take us from those first clumsy attempts all the way to mastery. Let's walk through it. And here's what that path looks like. It all kicks off with practice. Through practice, our brain starts to spot patterns. If you repeat those patterns enough, they become automatic habits. A whole bunch of related habits come together to form an ability. And when those abilities get really refined and integrated, that's when they become expertise. You know what's really wild is that this blueprint for how we learn, it's almost exactly how we're teaching machines to learn too. A machine learning model is basically a pattern-finding engine. It just churns through tons of data looking for structure, mapping inputs to outputs, just like we learned to map the symbol 9 and the tens place to the meaning 90. In both cases, intelligence comes from structure.
So, when you boil it all down, what's the big takeaway here? Learning isn't magic, it's architecture. Great abilities aren't these gifts you're just born with. They are structures you build, one small, repeatable habit at a time. So the real question isn't what you're good at, it's what are you willing to build?